Box down, I already said it last time, or else they're mine. Hey, or they're mine. This is a good one. I'm not making you guys fill in the entire thing, but if I was making you fill in the entire thing, if you want to practice, it's not bad. We're going to use it a couple times today. Question: what goes in the cheater chart for the unit circle? Ready, set, go.
Sine, cosine, tangent.
Sine, cosine, tangent in that order, right?
0.
Right, somewhat nicely, so I'm going to take more
0,
than
30,
How short take it is?
24 seconds.
Oh yeah, it was close. But that's too much time. Like you can answer multiple choice questions in that time.
Okay, good. Yeah, but that's by guessing.
No.
What? How fast do you get this?
Remember how we count it?
Well, 0,
0,
1,
1, 2, 3. This is Luca's way. 1, 3. No. Who does access in here? Not me.
Where's John?
Jason's over there. Square root of 3 over 3.
Are you trying to do George?
Nope, I'm just singing the song in the singing notes like he was singing. And then we have undefined and 0 right now. Okay. Wait, was someone doing it? Luca? You did a pretty good one the other day. Lonnie or Kristen? I don't know. Someone's going to say next one. Maybe it was Lonnie. It was impressive. So, why am I showing you this? For the entire chart? Well, yes, I mean, you're supposed to still know it. But, did you guys see in that formula what's in there? Tangent. So we get to focus on tangent today. And, guys, these are only the ones that are non-calculator problems, right? Because if it's not one of these angles, you're going to be using your calculator. But there might be a place or a time today where we have to go backwards from the tangent ratios, from the tangent answers, to the angles that they correspond to. So I figured it might be helpful if we just remembered square root of 3 over 3, 1 square root of 3 being square root of 3 over 3 with the 30, 1 being with the 45, square root of 3 being with the 60. And then if there are negatives and stuff, what does that mean? Where are we going to have to go?
Backwards.
Well,
The other way.
to an angle in a different quadrant. Please leave it at that for right now. To an angle in a different quadrant. Because in the first quadrant it's positive. In the second quadrant, what's tangent in the second quadrant? Positive or negative? It's not a t, so it's negative in the second quadrant. How about third quadrant? Because all students take t for tangent is positive. Fourth quadrant? Negative because calculus says that. So in the negative, it would be probably second quadrant for today at least. Sometimes it's the fourth. Positive is going to be in the first quadrant, but it could be in the third and other types of problems. Okay, let's go back to what you guys already wrote. We didn't write down anything in this review spot, but I kind of left it open and ready. What do we know about slope? Write this down. Rise over run. That's good. Let's write that down. I like it. Rise over run. If it's rise over run, aren't we going from 1.2? Wait.
Slope intercept.
I'm still on rise over run. Hold on. Rise over run. So we're going to have like a going up and a going over from one point to another. So there are always 2 points involved with slope, unless you're in calculus, then there's only 1 point involved. For question, does it matter what 2 points? Wait, wouldn't that be a different slope? And wouldn't this be even yet a different slope? Does it matter what 2 points we go to?
No.
Why not? They're all the same line. The numbers are going to be different as to the rise and the run, but the fractions are going to be the same. What's that called when like the actual numbers might be different, but the fractions end up reducing to be the same thing?
Does it start with the C?
I was thinking with a P.
Proportional.
Proportional is what I was looking for. Proportions, right? How they can be different fractions, but they equal each other. Anyway. Proportional. Or you could think geometry.
No.
Similar triangles? No, that's not fun. So coming back. Slope is rise over run. And even though we've looked at how the distances might be different as to the rise and the run, the proportions or the fractions, the ratios will reduce to be the same. So what's that formula? Caleb, will you say it? Someone was saying the formula. What's the formula? Okay, y equals mx plus b has a slope. Wait a minute, wait. Do you guys
Has
remember?
a slope.
Do you remember how I don't like that form of the line? What's the one I like?
Oh, you like point slope.
Why do I like point slope? What does that mean like that? No, it's because I teach calculus. Ask a calculus kid why I like it.
Because it's cool.
Because it's more helpful. Well, it's just more helpful. Like, you can use any point, you don't need to intersect. And in calculus, sometimes we do this thing called, we do some stick it to the man, where it's like, hey, it's right, I don't want to simplify it. We do that a lot more in calculus because time is precious. Or we're getting ready for the AP exam, where on the long answers, you literally stick everything to the man that you possibly can. Because if you simplify it and make it wrong, then they mark you wrong. You're like, yeah, not today. Anyway. So we like that version where we can plug stuff in and stop. Whereas slope intercept, you have to get all nice and pretty and on one side. Anyway, coming back. You asked, I answered. The formula, though, I was thinking about was the actual formula for slope. Was anybody able to fill that in?
X two minus y2 minus
Wise fly.
y2 minus
Y2 minus what for point slope?
No, for slope.
Y should be on top. Y's can fly, so Y's are the up and down. X is run. Here's a better way of saying that. You guys didn't have a chance to.
Yeah, you did.
How did he say it? Y's can fly, but what were the X's?
X's can die. Because if you leave this in a plane, then X's die.
He did not say that. That was Crawford. That was Crawford.
That was Crawford?
X
I
is
thought it
wrong.
was Duchesne.
It's Shane.
X can fly, Y can
All
fly.
Shane did was talk
problem.
about
So I think it's because this
I
is.
can text my ass
I
right now.
think this is too much.
Yeah,
for
yeah.
me.
He talks
This is
about Mormonism.
and isn't it?
All right,
this is too
Ricky,
much-
we're
this is too
past
much
the
on
helpful
skiing,
parts.
this is on skiing.
Okay, so all of this, M is equal to.
Right.
I know, I lost everyone just mentioning someone's name. M equals. M equals rise over run, y2 minus y1 over x2 minus x1, y minus y1. A slope shows up in a line. Sure, okay. We talked about, oh no, we didn't. This is all new stuff. Inclination. We haven't talked about it yet. Inclination. I want you guys to do, or to highlight, to underline, star, inclination, and then also highlight, star, underline, positive angle. So we can say the angle of inclination. The inclination is an angle. If you are inclined to do something, what does that mean, like English-wise? I don't know if it's you should. You kind of feel like doing it, right? You tend to lean towards this sort of option or this sort of action. You're inclined. You feel like it's a little bit different than this one here. This one's a little bit more like if you're going up an incline, right? Or an inclined plane. So maybe some of you have heard that before. What's that talking about? Maybe vectors, like ramps, yeah. Yeah. So something that is slanted, something that is angled, something that is, that's kind of what's going on here. I think if something that's angled, it might be an incline. Or has any of you guys ever been to Bakersfield or up that way? Have you ever gone up, let's see, isn't there a pretty big grade, a pretty big grapevine to get there? Have you guys ever seen when you're going up a hill, there's something on the side that shows some sort of like percentage of grade or the percentage of the incline?
Yes.
What's that for? Why do they have that? Yeah, why? Why is it so important for trucks to know that? How can they get out of control? It's all about the brakes, right? If the brakes get too hot? That's why they have those big old like runaway ramps.
Yeah.
Because going up, yeah, it's rough because going up, the brakes are working not the brakes are working so hard, sorry, the engine's working so hard. So the truck has to get up, that's true, and they say that turn off the air conditioner, do all this stuff even for cars, so that way you have more oomph to get up the hill. But for trucks, the more dangerous part is going downhill, because if they lose track of how fast they're going and then they have to slow down and the brakes don't respond, then that's hopefully the gravel will slow them down. Anyway, so incline, just think of an angle. The slope of, the angle of, the grade of whatever you're looking at, and in this case it'll be a line. Now, you wouldn't probably be traveling on a road like this, right? That'd be more like a skydive. So that one might be the whole like, you die because the slope is undefined. I don't know. But I'm not sure why X would die, that's kind of weird. But either way, there are different types of inclines if we're just talking about lines in general. We are going to have like the sloped up ones, like the uphill, and the sloped down ones, and the downhill. We are going to have the straight up and down, which are the weird ones, and then the straight across. You guys know what these slopes are though, right? What's the slope of a horizontal line? Do you remember?
What is undefined?
You people.
It's undefined.
You just by me not saying yes right away, you change your answer to a wrong answer. You need the right answer. Question, will you survive if you're cross-country skiing in that?
Yeah.
Yeah.
You won't be able to ski.
It's just not going to go very fast. The slope is 0. You have no incline. It's just flat. You have no incline. This one, you have an infinite incline if I want to be super snazzy. And we talked about this earlier this year. But I'll just say if you were to ski that, how's that going to go for you?
Well,
You're
if you're
soon going to
really
be
good.
undefined. Well, if you're still left. We talked about this first semester. Anyway,
Probably talking about.
that's it. You remember why you can fly, but not my cross-country skiing. Horizontal, m equals 0. Vertical, m is undefined. Okay? But how does that correspond to the angles that you see as to how sloped it is? Now, some of you are going to be like, angles? I don't get it. Why is the angle 0? I thought this was 0. If that was a straight line, it's not. That was 0. They're parallel. They are inclined the same amount, and they're inclined not at all, right? So when you're looking at incline, we're not necessarily measuring it from the x-axis, because some of you are like, I don't, but what, huh? We're just trying to see this alone, kind of like vectors in the sense that they can be moved elsewhere away from the positive x-axis. We're just trying to ask ourselves the question, how inclined is this? And we would say the incline is 0. Does that work in our formula? Cheater chart. M equals tangent of 0. What's tangent of 0?
0.
Oh yeah, okay, that works. So if the incline is 0, then the slope is 0. Okay, that makes sense. How about this one? If the incline is 90 degrees, what would the tangent of 90 degrees be? That makes sense also, right? Tangent of pi over 2 is the same thing as tangent of 90 in our cheater chart. Tangent of 90, 1 over 0. It's undefined, so that's okay. Now coming back though. What's going on with these ones? This is where it gets just a little tricky. If you didn't underline up above that word positive. You guys see the positive angle measured in standard position from the horizontal to the line? Okay. There are 2 different ways of getting to this line. One of the ways is proper for an angle of inclination, and one of the ways is improper. You see why going down is not the right angle to measure? Because according to the definition, inclination will be equal to what kind of angle? The one going down would be what kind of angle? Okay, so we're only looking for the positive one. Same thing with this one. We're looking for the positive, even though there is a negative, we don't want that one. Okay, we're sticking with the positive one that rotates up into the left, or counterclockwise. So we would call this one an acute angle, an obtuse angle, and more specifically, we would call this one, what kind of slope is this guy on the left? There's an acute angle of inclination, but what kind of slope is it? What side would he have? Positive slope, because you're going what? If you're traveling this one, you're going uphill, right? You're going up and to the right. This one, the line is decreasing as you go left to right, so this would be downhill. Just a quick reminder. So this one, m is greater than 0, and this one, m is less than 0. All right, let's go get to that formula. Another way of seeing slope besides the y2 minus y1 equals x2 minus x1 is to say that m is equal to tangent of theta. Wait a minute. How should that make sense in our mind? Why would rise over run equal tangent? Good catch. Let's get some random, I don't know, with an acute angle of inclination, some uphill line. If we were to take 2 points, and if I were to show the rise and the run, why did Jason just say opposite and adjacent? Unless that wasn't Jason. Wasn't that you? Yeah. Where's the rise? It's the opposite. Where's the run? Isn't that adjacent? Oh, so if rise over run is slope and opposite over adjacent is tangent, what can I say about slope and tangent? They're the same. Now, theta, we're just going to call what we did on the page before, the angle of inclination. We already highlighted how it needs to be a positive angle. And then m is going to be the slope of the line. Now, this begs a really good question. What do we do if it's not a line? Because angles, lots of different shapes can be angled, not just lines. So could there be slopes of other things besides just lines? That's calculus. We'll wait until section 10.2 to talk about it. Just for a little bit, though, not a lot. In 10.2, you learn how to use geometry. And what we're doing right now in Precalc, what we will do in section 10.2, to do what calculus solves a completely different way, which is kind of cool. So we're just going to intro a little bit of calculus. That's it. Guys, in the example, they gave us two different lines, right? Does anyone remember that really awkward way of writing a line? It's not your way, point slope. Sorry, it's not your way, slope, intercept. And it's not my way, point slope. What way is that one? I heard it. It's standard. AX plus BY equals C. It's not a bad way of writing a line. The only problem is you have no idea who anybody is. You can't see the intercept, you can't see the point, you can't see the slope.
So it's a bad way of writing it.
Basically, I don't like the way it's written right now, so what are we going to do?
Change it.
Change it. How?
To something else. That
We
is
took algebra, we can move stuff, yeah? How do we move stuff for the first one?
give up.
You give up on moving? Okay. So we start with our original equation of x minus y equals 2, and we say, who do we want by himself to see the slope clearly? Yeah, y equals mx plus b. So how do we get y by itself? What would you guys think of doing first? Because my brain usually thinks differently than yours.
Subtract x divided by -1.
Okay, that's what I figured you were saying. Subtract x. Does anybody think about adding the y because they don't like the minus? That's just me. I just don't like the negative. I would have added it and been like, ugh, add the y, subtract the 2, but that's what most people would say. Most students would say. But if you subtract the x, don't you dare forget the negative in front of the y, right? Okay, now what? Okay. We gotta go with what your brains would say because that's what's gonna come down to on a quiz or test usually, right? What am I doing right now? Yeah, I'm moving the negative. I'm getting rid of that negative by the y. I don't want him. A negative times a negative, you can multiply or divide. We end up with a positive y equals. You guys okay if I see that the x will be positive, so I write him first, and the 2 will be negative, so I write him second? Is that okay? Wait, what am I looking for again? Oh, inclination. Why am I trying to rewrite my equation of my line? From a line I can find m, and from m I can find O. So what's my m in this equation? You guys know that, yeah? There's no number in front, I understood 1 is 1. So then I can say m is equal to 1. So if m is equal to 1, what else is equal to 1 from my formula up above? Okay, so go, well, tan of theta. Just because in this one we have an x meaning something already, so we want theta instead. How are we supposed to know when tangent of theta equals 1? Square root of 3 over 3, 1 square root of 1. Hey, what angle was that? 45. It's halfway in the middle, right? So we have 0, square root of 3 is that 0, then 30, then 45, then 60, then 90. So square root of 3 over 3, 1 square root of 3. So we have the 1. I just changed keys, I don't know why. So theta is equal to pi over 4 or 45 degrees. Look at that. Didn't even have to get out our calculator and do any tangent inverse weirdness. So you guys, you got this. Go move around, letter B. Ready, set, go. Then see if you can use the same trick of maybe it's a special unit circle one. If not, we'll have to go to our calculator. we'll have to use tangent inverse the button, second tan. But if it is a special unit circle, we can jump to an answer like in this one. You have not yet. Ready, set, go. Is it a special unit circle one? No. So we're going to have to use our calculators. Oh well, sometimes that must happen. Do you guys at least move it correctly though? Check it. Subtract the 2x, divide everything by 3. 6 divided by 3 is 2. You have to divide every piece by 3. So m equals 2, negative 2/3, I apologize. Okay, it's not a square root of 3 over 3, 1 square root of 3. Or 0 or undefined. It sounds a little laughing on that part. But how do I solve it if it's not one of those special ones? Tangent inverse of both sides. So I throw in tangent inverse of, and I throw in tangent inverse of. What happens when I take tangent inverse of tan? The next part, it cancels it away. What happens when I take tangent inverse of negative 2/3? Someone give me an answer, just tell me radians or degrees.
Radian is negative 0.588.
Negative 0.588. Our brains don't think well in radians. Can someone get me the degree one? Negative 33. Does anyone see, I'm going to say 33-ish because I ran out of room. Does anyone see a problem with a negative angle of inclination? It has to be a positive angle. So how do I, oh no, it's one of these again? No stress, not minus though. Oh, 180 minus. When you say that, Caleb, it just makes me think of minus a negative and it'll mess it up. But if I do 180, take away 33, and how does that work? Remember how negative goes down? And I need to say, well, wait a minute, hold on. This line keeps going up, right? This just is going the wrong way. I need the angle that goes the positive way. And the positive way one is going to be the supplement, or what makes 180. So then some of you already figured out 180 minus 33 is approximately 147. I know, I lost my decimals somewhere. I just ran out of room to fit one. But we'll say approximately 147. Is that a positive angle? Yes. Does it still show the same line as negative 33? Yeah, so we're okay. That's the inclination. So wait, is anything going to get any weirder than that? Except this is kind of backwards. They're giving us an angle this time, and then they're asking us, how do we do that? I can do it 2 ways. I could say, hey, I know where that line is. That's my 2 pi over 3 because we know the unit circle. And I say, okay, what would the slope be? The rise over the run. Oh, that's right. Wait, I have that nice formula. The slope is tangent of, plug it in. Right? Uh-oh. 2 pi over 3. It's in the second quadrant, which means tangent is negative. Wait, shouldn't we know the slope is negative anyway? Downhill, it's going to be a negative slope. But pause. 2 pi over 3, is that a square root of 3 over 3? Is that a 30 degree? 145. Square root of 3. It's a 60 degrees, so it's just going to be the square root of 3 one. If you did it in your calculator, you would have some sort of weird decimal, something. But remember, 2 pi over 3, that's 60 degrees off the 180 line. So we can use our square root of 3 over 3, 1 square root of 3. It's that last one. Okay, so if we have a line, we can get the slope and get the angle. If we have the slope, we can get the angle. We can go multiple different directions with this. What if they give us 2 points? Oh, silly. They didn't give us the exact slope, but we can just plug it in real fast and do y2 minus y1 all over x2 minus x1, right? And pretty quickly, hopefully you guys could see combining like terms. I have 1 root 3 minus 2 root 3. Throwing things at the classroom. Is she helping you out?
Yes.
Oh, wait, but we're not done. That's just the slope. What do they actually want? Oh, there's a formula for that. Square root of 3 is equal to? Yeah, I was looking for the formula first, but then say square root of 3 over 3 minus square root of 3. What equals that one down? 60. Huh, that's easy. 60 degrees, or if you want to be really snazzy, could you say pi over 3? Nice. Now some of you might think that's all there is to this section. You're almost right. There's one little thing that we were going to do a discovery of, but in lieu of time, I'm still 35 seconds, write down the second important formula.
Oh.
I have 10.1 due tomorrow, and you maybe could, if you're good at just plugging into formulas, you could maybe do it just fine. But we'll finish up these angle between examples and start 10.2 tomorrow. So we're going to not check homework until today's Wednesday, Thursday, Friday. But 10.1 is easier than 10.2 homework, so if I were you, I'd get going on it 10.2 when we start it. Best if you can start it little bit by little bit every night, okay?
Let's
Those
do
of
the
you that didn't do
corrections.
homework last chapter, little bit by little bit is better. Corrections always go in top.
Yeah, I thought so.
I want to see that before the test. Bye guys, see you in couple. Assembly. Singing Bob and Jim.
There's something to do right now.
We're doing that.